My name is Holly, and I will be talking to you about the optics of water. Now, when you first start to think about rendering water, the first reaction you have might be something like this. But don't worry, because I'm going to simplify this complex topic for you. The basic concept to keep in mind is to not think of water as a thing, but as a medium. Think of water as an effect. So let's first talk about the color of water. Water is effectively transparent, although it does have a slight blue tint. Small quantities appear colorless, and the blue tint will become deeper as the thickness of water increases. Impurities in water may give it a different colored appearance. The easiest way to think about it is D2 as a combination of depth and dirt. Now let's talk about the angle of incidence. Basically, just know that the angle we view water at determines how we perceive it. A shallow viewing angle means mirror-like reflections, and a steeper viewing angle means seeing into the water. Just think if water is closer to the eye level, you'll see reflections, and if you're looking down, you'll see transparency. The angle of incidence causes the fractured appearance of broken water, sun streaks, and is a cause for why the near side of a wave or ripple will always be dark. Water interacts with light in four basic ways. It scatters light, acting as a light source, absorbs light, acting as an object, reflects light, acting as a mirror, and refracts light, acting as a lens. When water scatters light, it creates a soft, pervasive illumination, and is responsible for the soft blue glow observed underwater, similar to atmospheric perspective. Sunbeams are created as light passes through water, scattering preferentially forward. Foam and whitecaps are white because they are made up of small bubbles that scatter light very efficiently. Water darkens form and lowers value by absorbing light, so wet objects will appear darker. Water absorbs the red end of the visual spectrum, causing red objects to appear black and cooling warm colors. In underwater photography, warmth can be achieved by using a flash. Water efficiently reflects its environment. You should note the vertical bias in reflections. Smooth water will result in a mirror-like reflection, while rough water distorts reflections like a warped mirror. Fractured water creates many small planes that smear reflections, as can be seen in sun streaks, moon streaks, and even lightning streaks. Total internal reflections happen when light gets trapped inside water, because light cannot pass through water at an angle greater than 45 degrees. Water focuses and defocuses light, making objects appear to be shallower and closer to the observer. Water focuses light to create bright areas, and these bright concentrations of light are known as caustics. So when thinking about waves, know that waves are energy traveling through water. Waves are moving trains of energy with depth and width. Waves cause water particles to move in an orbit and do not actually move water. Waves are created by a disturbing force such as earthquakes and landslides, and a restoring force trying to bring water back to a level surface. An example I give here is throwing a pebble into a lake. When we think about waves, we're usually thinking about waves created by wind. Wind creates waves by blowing across water, creating friction and transferring its energy into the water. Generally, the stronger and longer a wind blows, the higher the waves will be. Waves occur on the surface of oceans, seas, lakes, rivers, canals, and even small puddles and ponds. Whitecaps are the bubbles and streaks on the crest of breaking waves. They happen on waves that cannot grow any larger and must dissipate excess energy. Waves slow down as they approach the shore. Energy is pushed up as the wave encounters insufficient depth, causing the wave to grow higher. The bottom portion of the wave slows down as the top continues at the same speed and curls forward. The wave breaks as the top overrides the bottom, and you can think of this as the wave tripping over its own feet. Waves break under two conditions: as a result of insufficient depth, as I just talked about, and open ocean deep water breakers breaking as a result of becoming too steep. Waves can be as small as a ripple or as large as an ocean breaker. These are the main ideas you should keep in mind when trying to render water, and hopefully now you feel comfortable with the topic of water.